So let's start the today's session. So we are going to solve graph data structure, that's the minimum spanning tree and distance set. So we have to learn like chemistry theory, like minimum spanning tree. You can learn on GFG, right? Chemistry theory, right? What is minimum spanning tree? You can read about this all book log. Okay. Now we have to Prim's algorithm, right? And disjoint set. So for disjoint set, you can see that the striver here. Now we have to solve find the MST weight, right? So yesterday I was not able to go live, but I solved yesterday I solved this problem using, right. Let me show you. Yes, I solved using problem this joint set, and you can also use like a Prim's algorithm, right? I solved this using the Kruskal algorithm. It is a Kruskal algorithm, right? And this is a Prim's. What is Prim's saying that both are greedy approach, but the that a Kruskal say that it sort according to the sorry, I think postman is required. So like a Kruskal is said like a Prim's sort Prim's algorithm. You can learn about this. It is greedy like Kruskal, but start with the single nodes and move several nodes, explore all the edges. That you have to take like visited or minimum. You have to take two things, visited or minimum. If it is visited, you can't take the weight. If it's not visited, you have to add the edge. We can use to priority queue because it gives the minimum sum of that node, right? So let's. Hmm. So this is not good. Hmm. Let me show you my code. Okay, not a yeah. See, this is the Prim's algorithm, right? We are using the visited array or the priority queue, the minimum priority queue, right? To minimum. So we have to just do with her extra like algorithm, but we have to use a visited node. That means if it is visited, we can't take that sum, right? If it's not visited, we have to take that sum, and we are traveling and taking a minimum sum. That's is the Prim's algorithm, right? Now we have to move like I have solved yesterday. I solved this problem, and this problem, and this problem. Now I have to search for making a larger island and search. Okay. What is this question say? You are given an end-to-end binary matrix. Okay, you are allowed to at most change one. Okay, return the return the size of the largest island in grid after applying the operation. Okay. So what can we do? 1001. We have to take like a what can I do here? Like we have to take we can take a like make it connected. So it's not okay. Node should be So what I'm trying to do is like, let's suppose we have to give that at most one, one, 0 to 1. We can change, right? So what we, if we have to find first let's find a group, right? Let's find the group, like how much is connected with a single group, and try to make a bond between the largest and the second largest. Okay, we try to make a bond between the largest and the second largest. Then we try to bond. If it is 0, if it is 0, we can try to bond between the this one and this one, this one and this one. Okay, and try to maximize it. Okay, so let's suppose first we have to solve. Like first you have to solve. Let's take a n, like grid dot size. Okay, m grid dot 0 dot size. Okay, and take a node. Take a node should be n plus what should be the node, like 0 1 2 3 4 5 6 7. So node should be n into m plus 1, and and we have to take a parent resize resize node, and rank dot resize mx 0, right? Now what we have to do, like like we have to do like we have to do travel all the way. Yeah, you can go like 1 dx 4 is equal to 1 minus 1 0 and 0, and another one like dx 4 is equal to 1, sorry, 0 0 1 and minus 1, right? Now what you have to do, just you have to do like travel travels. Okay, take a visited, right? You have to take also a visited, or you can take not to visited. You can take like a so so like what we have to do, like rank or size, which is the most efficient here. If it talking about the rank or size, what should be the efficient? Like if the rank, if the my parents in this and this, we have to take a, like I think I rank is not good, but the size is better here. Like we can find the size. Uh, okay, yes, we can find the size. Let's suppose rank. Hmm, okay, okay. So finding the rank. Okay, okay, okay. What we have to do, like rank should be right. Okay. So let's suppose travel all the way, all travel all the node. If the grid ij equal to 1. You have to first mark it down like grade I and j is equal to 0. Okay. Now what you have to do? Like you have to do like travel all the way. From that, you have to apply the like the greedy algorithm, right? So sorry, not a greedy, but a BFS algorithm. I think so. You have to apply the BFS, right? Market grade, and BFS IJ, and multi-source BFS. I think we can use the multi-source BFS, right? What to use that much BFS, right? So just do one thing, like take a Q dot push I and J, right? Take that much and mark it down like grid I and J should be 0, right? Take a Q pairwise int and Q, right? Good. Mark it down, multi-source BFS. Now we have to just do what? While Q is not impeding, like auto T, what? Q dot front, Q dot front, and Q dot pop. Okay. We have row Q dot first, and C Q dot T dot second. Now what we have to do? Like we have to travel all the four sides. All the four sides we have to travel. Like NR should be the R plus NR, sorry, DX II, and NC should be the NC C plus DY II, right? Now we have to just like if it is out of the bound, like NC should not be out of bound. We have to just continue if it is out of bound. If it is visited, okay, and also if it is one, not one, and C and NR is not one, not equal to 0, you have to continue and take a element should be previous node should be what R plus R into M plus C, right? And next node should be, and new node should be previous, market previous node, right? Previous node and new node what? NC into M plus NC, right? And mark it down like unite of NC, like previous node and previous on previous node and new node. What I am doing here, I am just making the group wise, right? Making the group, that means combining the group. Now we have just completed this one. Now we have to take a vector array, vector in temp, and we have to just travel all the way like mx plus plus, like mx plus plus. Okay, so n plus 1 to plus 3. So you have to travel not to take a plus. Okay, and take like the ultimate parents is equal to find parent of I, and take a map like MP ULP plus plus, right? Take an unordered map unordered map, int, int, right? Int, 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 MP. Now let's suppose we have to travel all the way MP and temp dot size, temp dot pushback, temp dot pushback. You have to travel temp dot pushback and x dot second. Okay. Now just sort it out like temp dot rebegin and temp dot reend, right? And just return the like if the temp dot size is greater than 1, you have to just return the temp plus and temp 1, right? Else return the temp 0. This one for all this. Now just make a vector int parent and rank resizing this. Now int find parent, we have x. Now let's suppose if the parent of x is equal to x, you have to return the x. Else you have to do a path compression, like path compression should be x equal to find parent, call the recursive function parent of x. This one good. Now you have to take a unite, like combination. What should be the combination? Like we have u, you have v, we have v. Now find the ultimate parents, like ultimate parents of u is equal to find parent of u. Okay. Now ultimate parents of v is equal to find parent of v, right? Now what we have to do? If the ultimate parents of u is equal to ultimate parents of v, you have to just nothing to do. You have to just return, right? Else what? You have to do like the rank of ultimate parents of u, but the ultimate parents of v is greater. You have to just swap it out. That means you can apply, but I think this is the like we have I think you have learned the like a disjoint sets. So you know that we are adding a smallest rank to the biggest one. So now if the like parent of L, like L u, ultimate parents of v should be the ultimate parents of u, and the if the if the rank of ultimate parents of u is equal to rank of ultimate parents, the rank of ultimate parents of v, what you have to do? Just do ultimate parents of u plus plus. Let's see. Let's try to. Now it's giving compiler error. Why? Temp. Okay. Temp dot size, not a temp. If it is greater than equal to, yeah, else we have to. Let's try to see it's giving the right answer. So it's giving the wrong answer. Why? It's like 3. Okay. 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 If it is 0, you have to just not to do that. If it is 0, you can't make it connection. Okay. See. If yes. Okay. 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 You can't take it like we are taking all the one, but we have to take only that much which is used, right? Which is used. We have to take only which the elements which is used in here, like one we are making. So you have to take a like you have to take only that solution which is the used. So we can use like here temp dot size. So we have to take like a previous unit. So what we have to do? Take a map here. Take a map one on order. What is the spelling of order? Order, like order, order, map, like in here it is use node, right? Use node. So here use node, used, use node. Node should be what? Use node should be the like RC. Okay. Use node should be the here. Use node should be the what? NC plus like use node should be the what? We have like a new node, new node plus plus, and the and use node should be the previous node plus plus, right? We have to just do we have to just take like only the use node, right? So int x x and the use node use node use node, right? Use node, and here we have x dot I should be x dot first one. Let's try some. Let's try to do see that it's giving the runtime error. Why? No, why this giving the runtime error, right? So it's like use node int x should be x finding the parents x, and x should be first. Use node should be this. Okay, so it's giving the 3 expected 3. Okay, okay. The size of the group return the largest challenge group. So it's plus one, right? It's a plus one. It's plus one. Like size of the one plus size of the two, right? Like a one, it's a one, it's a one, it's a one. So one one. If we add one, so it's a one one. Okay, so it's more like a one. Okay, okay. This one is good. If we're taking the one one, it should be one. But what about that? If we take that not to one as like let's try to see what is the value of the temp, right? Let's try to see the temp value, right? No, sorry, skip. Let's try to see the temp value x. Let's try to see the temp value. What is the temp value, right? Like temp value should be two, only two. Uh, I don't think this is the right one. Why only giving the two? Hmm. Okay. Used node. We can't go. We can't go. Ultimate parents of this. Okay. 3 3. Like 1001. So if we are using that much, so this one 00, so it's 0 0. So it's like 0 node and make a connection 0 with, there is nothing, so we can't do anything. The port side. Now we have this, we can't do anything of this side. Okay. Then we are taking one node. Okay. I am making mistake somewhere. I think I know, but we are not marking a parents, right? We are not marking as a parent, so we have to mark it out. All mx, all mx plus parent should be x is equal to I. Now this should be the returning right values. We are leaving the parents. That's why this like is giving the 1 1 1. Okay, 1 1 1. Okay, like 1 1 1. Now in the second case we have for the third for one case, for the second case we have like the 1 1 1, right? 1 1 1 1, right? Like we have 1 1 and 1 0. So it's 0 0 and combining with 1, combining with 2. So these all are marked 1, right? So it given, it should be given, right? When ultimate find the ultimate parent, and this should all given to the 0 0, mark 0 1. It should be 1. Mark it all, or okay. I'm making mistake. Okay. Do not push. Just sorry. And see, and again combine with the night. Combine. We taking this one. This one should be this one. This one should be this one. Okay. 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 So I think we are making mistake here. So we have to use another way, like using the BFS in different manner, right? Okay. We are market at 0. Then no doubt. Okay. 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 Used void BFS, void BFS vector BFS int R int C. What we have to do? Just you have to copy from here. You have just copy from here. Copy, paste here, paste Q. You have to do Q dot push back R is C and mark grid R, grid R and C is equal to 0. You have to just remove from here and you have to just copy from here. Like copy this much, copy from here, remove from here, and just you have to do just go back here. Again you have to just do what? You have to just do call the BFS function, B, BFS, BFS with the grid and the I and J, right? We are calling, we are marking all the function, okay? last use function. Now again we have to ultimate finance. Now we have to do like that. Let's try to see, is this the giving the right answer? Like the R and C, what is R and C? So it should be the different R, right? It should be different R, C. So it's like the R and C and R and C. Now we have to just moving forward and trying to put it why this giving. Okay, what is M and C? What is M? It is not given. So it's you have to copy from here. You have to paste here. Let's see. Like traveling all the way, mark it on down and see previous. Okay, time limit exceed. Why this given the time limit exceeded? We just market it like grade I and CS should be 0. We are market it out. We are market it out, and you have to just do here one thing more. What you have to do? Grade, grade and C and NR. NR should be 0. You have to do here this much also. Let's try to see. Yes, this one. Good. Now we have 3. Okay. 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 Like now the question arise like this is good. This should be good, right? Like we have 1 plus 1 it's 1 plus 1 it's now the question arise like if the temp dot size if the temp dot size is equal to maximum, right? If the temp dot size if the temp dot size is equal to like maximum minus 1. Okay, it should be like a maximum minus 1. Why I'm saying that like 0 1 2 3, so it's 2 into 2 4 plus 1, so plus 1 5, so minus 1. if it is if it is greater, then you have to just do one thing like temp 0, else you have to do temp 0 plus 1. Okay, now this should be pass the test cases. Let's try to see. Let's try to see, submit it out. It's passes all the test cases or given the wrong answer. Runtime error referensive binding, integer value. Okay, 0 0 0 0. So it should be returning 0, right? And what should be if there is no one? Ah, okay, okay, mm, okay. If it is size 0, if it is empty, if the term dot empty, you have to return 1. You can mark it up. You can make it into 1, right? This giving the wrong answer. Why? Okay, 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 okay. 1. So like 1 into 1. Like size. So it's more like 18. Why 18? It's 15, 1, 1. So it's converting 15 and 1, 1. Okay. We have 15, 1, 1. So it's the 16 or it's 18 now. 17 plus 1. It's 17. One connection is 15, one connection is 1, one connection is 1. So we have sort them and try to take a maximum. Okay, maximum. So it's the 15 by 20. We found like the maximum bonding is 15 and maximum bonding is 1. If we connect them, so it become a but. One edge cases like if it is 15 and we have like if it is 15 and we have like here we can go like 15 and here we have one more connection, right? So, like this and we have this and we have this, we have this. So what we have to do? What you have to do like if I become the 0 1, if I become the 1, if we put any place which is probably just 0, if I put 0 there, so we have to check check bro, check bro, check bro, check bro. Okay, check. So we are checking if it is if it is not connected, we can connect that much and size should be take a size. If it is not connected, take a size. Okay. If it is not connected, take a size. Okay. So I think the rank with the rank, I think the size is best solution here, not the rank, right? So what I am doing, what I am trying to do, like what I am saying, like uh, like the first of all connect all the ones, right? Now travel all the each the 0 and try to connect it all four side, which is all four side, all four side, and find out if it is possible that we can get the maximum, right? So just like this, we have to try this out. Like what I am trying to do here. Mm, Not a rank, but take the size, okay, and take a one. Inside the side, you have to do one thing. Like this one is good. So you have to do test. That means size. What you have to do? ULP, ultimate parents of U. You have to plus ultimate parents of okay. Ultimate parents of you have to do ultimate parents of size of ultimate parents of V. This one you have to do this much. So it's become size. Now you have to take all the ones, all the one, and connect all the one and connected to all the one with the 0. Now you have to just do. You have to take a visited array, right? You have to take a separate visited array, right? Take a separate visited array, not one. Okay. You have to take a separate visited array. So we have to take a separate visited array. So let's make a visited array like a vector bool visited and 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 vector bool visited. You have to take like a visited visited m and mark it as false. Okay, and you have to just do like if it is not one, if it is one, and if it is visited, not visited, like not visited, ing. If it is not visited, you have to go call the BFS, and here we have to do what we have to do. Not to mark it 0, we have to do visited and mark r c is equal to 2. Mark it visited. Now you have to just remove this extra space like which are taking by the UI node. You have to just remove, and you have to call like call a sorry, you have to take a visited area, right, and mark it down. Now we have to just do one thing like here we have to also mark it down, or like r and c is equal to true, right. We have to mark it down. Now we have to just put it up. We have marked down. I just remove this. We marked all it out. Now connected all it this. Now we have to just do one thing, just remove from here. Now the question arises like how can we do like making a combination, right. We are make all the combination, right. We make all the connection. Now we have to just do like checking for the conditions. Like how? So we have 0 and plus plus travel 0 m plus plus like if if grade I and j is equal to 0, we can make a connection. Like we can travel all the four way. Like one connection is like one connection is one connection should be what? Like one connection should be. Let me let me let me first run it. Okay. So what with the edge cases like making the connection with the four? So we have to check this out, right? So like we are like here, 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 all connection. So like so if we mark it is now, so this size, if you mark it, tell me the size of yours, tell me size of yours, size of yours, and size of yours. This is good. Now again, we have to just do like we have to, what we have to do. Like we have to travel all the four way. If it is visited, if it is like so, what you have to do is copy from here, remove from here, just paste here, and take it like take it like okay. So take it like that much. You have to take like to make the connections. Now you have to take like what? Like if it is one, so if it is one, you have to take like this. You have to take okay. You have to take like you have to take like the parent ultimate parents of that much. So you can use the set data structure because it might be the possible, right. They contain a duplicate, right. They contain duplicates, so that we have to use set. If it is uh, if it is that much, Like so you have to travel the all the four way. You have to travel all the four way. Okay. So just do one. Okay. What do you mean again writing that code? Just copy from here. Just copy from here. Copy and paste it here. We have travel all the four way. New node and the previous node should be what should be previous? Just previous. Previous node should be what R into M plus C. Now what we have to do? Like you have to just nothing to do. Like a node, not should be node, right? You have to just not required to previous. You have to just and st insert insert find 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 the parent, right? Find the parent of new node new node, right? Find the parent of new node, and after coming out from that section, coming from the that section, you have to take a in total in to total is equal to 0. You have to do auto x and the st, and you have to do this total plus is equal to, you have to do plus is equal to size 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 of x, right? And you have to just maximize the answer, maximum maximum answer and the total, right? Just just take a just take a answer equal to 0, and you have to just return from here answer. Now the question, now this is clear, very clear. Now let's try to, okay, let's try to see. Okay, I am making mistake anywhere. Okay, giving one vector bull, my code where I am making mistake. Let's see. Like this all good, void this good, this all good, vector visited nodes, this all good, and plus one good. I is equal to 0 and not visited, then we have to take it into granted. Take it as granted. Okay. So why this given, like which error should be plus one? Okay. So I think one mistake is like 0. Here we are all good. Now we push back, taking four directional marking. This one is good. Four directional. Now for the web, this one is good. For the while loop, and for the last, this should be good. This should be the BFS call. This should be good. This should be good. Now again we have, if it is like we are inserting here, and okay, we are making mistake here. Just copy from here. Just like like making a connection here. Good. This is good. This is good. Now traveling all the way. This is good. Now this is good. Now for the four, this one is good. Just take one. Okay. Size ULP. Okay, so we have to take different, right? Size is not defined, so SJ. Sorry for the inconvenience, right? SJZE. Take a SZE. Take a SZE. Now let's try to see again. Did you mean side? Bro, I mean that not as ready. दिल पे जख्म खाते हैं as ready. BFS. दो महीने बाद you have to call right. That means good. So visited. This is good. Visited should be this. Like, okay. Set data structure. Let's stick. Time complexity. Why this giving me the time complexity? Yeah. Why? Just why you are giving me the time complexity? I'm traveling with your whole direction. If it is not, you have to just do one thing. Just why you are doing that time complexity is this. Pseudo who's calling for the function, marking as if it is unvisited, and if it is one, you have to call the post I guess. Okay. Just do one thing. But mark visited, visited MC and NR should be zero. Sorry, should be true. If you mark as visited, we have traveled not that much. We have traveled that much. Zero. Oh, again, time complexity. Why this giving the time complexity? I don't understand that much. Why, bro? Why are you doing the time complexity? Just why? I am visiting, I am marking, I am uniting with you all. If it is one, you have to terrible. You just call this much concern. If it is zero, you have to continue. If the grade, if the grade I and J is equal to zero, you have to continue. You have to continue. Continue, continue, continue. Continue, continue, continue. Continue, continue, continue. And in this question you have to if it, if you have one if you have one you have to just continue. Continue. You have if it is one and it's j is equal to j is equal to you have to just continue. We are continuing. You Nodes should be the finding parent should be initial value, maximum value. Now this should be, this should be, this should be, this should be, this should be. Take an unordered map. Why are you here saying taking the ordered map? Take an unordered map. So it's like unordered, unordered, unordered map. Unordered map. This one is good inserting, finding the parents. It's previous, so you can't take going all the way, going all the four way, going all the four way, I plus j and j plus 1. And if it is, so you have to take it. You can't take it like just remove that much solution. Just 4 and auto and size and returning the answer. Why this giving the wrong answer? Well, why this giving the time complexity? My question is that I am making mistake here. RNC travel four ways, travel four ways. Okay, just remove the BFS algorithm, right? Just remove, try to remove it. BFS algorithm. Just do one thing. What? Just do one thing. Like we have 1 0 continue, so we can we can do like same approach here. Same approach here. Copy. Okay. Like we have ij plus 1. So ij plus 1. It's continue. And if it is, if the grid NX and NC is equal to 0, you have to continue. And you have to, like we have two options, right? Two options like previous node is equal to right I into m plus j, and new node should be, new node is equal to what? New node is what, like nc into m plus nr, nc, right? Nr plus nc, and unite them, you unite 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 them, what? previous Previous node and the new node. Okay, we have to unite them. Okay, this much good. Now we're taking like this much is good. We are taking this much. Now we have to take this much. Okay, this is for the for loop. Now we have to just do one thing. Let's try to submit. Okay, this one is good. So it's giving the 4. Okay, 4, 3, 1. Okay, so you have to maximize your more, like you have to travel like j and j plus plus, and you have to do a thing. At last maximize the answer with answer and like as the as the like find the parent with ii is the final conclusion. Like yes, this is good. I think we are making mistake somewhere else. So this is giving the why this thing for, okay, we are taking 0. So I think we are making mistake. Like one should be now not the right. Okay, let's suppose let's suppose we have to just mark it out, like if it is 0, you have to take it out. And only you have to take like find the first, yes, like the grid and cn and r. If it is 0, you have to just continue from that side. Yes, let's try to submit it out. Yes. So this is like good question. First I tried like making from the BFS, but it's taken a lot of time. Then I go that much. I'm making the connection and then try to optimize that connection, right? Optimizing that connection. This one is good. So this approach is well done. The question is like why are you doing that? It's it's for like if we can't find like anything, so we have to maximize, right? We have to maximize like all the connected nodes. If all the cell is connected, so you have to maximize that answer, right? Because you can't find zero here if it is all connected. Okay, now let's move to the next question. Next question is swim in a rising water. What is this question said? Let's try to solve this question. You are given an end-to-end matrix grid where each value represents the elevation at the side of Itna. It start raining and water gradually rise over time. At time t, the interval, the water level is t, and after any cell with elevation less than the t is submerged or reachable. Okay, if it less than reachable, you can swim from a square to four directional. Any other only if the elevation of both individually are at the most t. Okay, you can swim the infinite distance in 0 seconds. Okay, of course you can must stay within the boundary of the grid during the swim. Return the minimum time to reach the bottom if you start from the starting. Okay, so starting the time was start. Now else you can get there for the action. So it's, if we get if we go from here to here, if we go from here to here, it's like what we have to do. So I think we can use the binary search here, right? What is the minimum time? Like, can I use the binary search here or the DSU? Binary search DSU. Like, if we take that two, can I reach into two? Yes, two. No, no. Yes, two. Can I take the three? We can reach from here. If we take like, if we take like 15, so can I reach from the 15 from here? Yes, yes, so how can this question be related to like DSU? We can use here binary search. Like binary search. eh, Let's try to solve it using the binary search, right? First, we try to use binary search. One answer, like we have taken the 15, so we can go here. Okay, press hold frequency. So let's build it. Let's it's like 16. Okay, 16. So in start 0, in 1e9. Okay, in answer Wahid ST Wahid ST. Now we have to find mid. Mid should be ST plus in this now check. What should be the check? Check should be the grid and the mid. If it is, we have to answer. We have to answer and we have to minimize, right? We have to minimize the time until you reach the. So for the minimizing, we have to like end should be mid minus one, else ST should be mid plus one, right? And we have to just return the answer. Now the calling that. bool function check. You have to do, you have to take like grade this threshold. This is the threshold, right? Threshold time. Now you have to take like a like what? Like Q data structure, pairwise Q. Now we have to take a visited array, right? We have to mark it. We have to take. We can have to take a visited. Let's suppose you don't have to take visited array. Like no. Let's take a visited array. It's for our benefit. None. Size. Now take a vector bool visited and vector bool and false. Right. Just you have to do like a visited 0 and 0 to be 0. Okay. Now q dot push 0 and 0. Now we have to do what we have to do. Just apply the BFS algorithm here. Q dot entity. Just apply the BFS algorithm, right? Just apply the BFS algorithm. Like workflow P Q dot front Q dot pop and what int r is equal to t dot first and t is equal to and c is equal to t dot second. Okay. Now the question is like if and if we reach and is equal to and c reached m is equal to, you have to return true, and else you have to do travel for the direction, all four direction, like int r is equal to int new r is equal to r plus dx and new c is equal to c plus dy. Okay, and if it is nc less than or nc or nc greater than equal to m or nr less than equal to and nr greater than equal to m or or the value or the grid value and the grid value m and nc is greater than the threshold, right? Threshold, you have to just continue, right? You can't go there, else you have to do, you can go there, and see nr and mark as visited and see right and see and 3 is equal to true. Now you have to just return here false. Let's try to see this passes all the test cases or not. Okay, IDX I not define, so yeah, I can define it for 1 minus 1 0 and 0. Again dy 4 is equal to 0 minus 1 and 1. Let's try it. Threshold Time limit is time limit is where I'm making mistake. Q dot push. Q dot true. Traveling four direction. IX. If it is greater than threshold, you have to continue. You can't take that. Else you have to just NC answer and market visited. Okay, yes, this is good. Oh, why this giving the like why this giving the like okay, what should be the size? N square. So it's 50, that means 100. You have to just like 1 50 into 52, 2.5, right? 50 into 50, 200. That means 25001. Just take that much. Just take, just take this much in HT plus 1 and minus 1. This one is good. Why is this not giving the right answer? The question I write like that. We are giving all this four direction. We are moving that direction, making the poles pairwise, taking the end, and again CT, your TT. Okay, we are traveling all the way. If it is threshold, we are continuing. If we are marking as true, we are taking this much and posting that much. You have to take threshold and answer. And if it if we found that means plus one, then you have to travel that much. So that's the question. I like why this giving the time complexity might be give the solution wrong, but giving the time complexity pseudo empty for RC and minus one truth and truth false direction. You have to continue, right? You can't. Yes, sir. You have to continue. Mark continue. Like from there here here, from there here here, from there here here, from there here here. You're traveling. You can't go from there here. It's a 16. So if it reach the 16, you are reached and log in mid. That means in a start mid plus one. It is true. Why is giving the wrong time complexity? Why time complexity? Let me try. Let me see. I think I made a mistake somewhere. Like, we are traveling in four direction, all four direction. Okay. Now we are checking for this should not give the clearly, right? And it's quite 50. I know the BFS is like using the BFS, multi-source BFS, like and a square and log n. Like log n should be the okay, 50, 50 and Q. Maximums and Q. Then why it will give the TLA right? HT plus 2 SPS 2 plus 1. Okay, okay, okay. Just if it is visited, you have to continue, right? Yes. One answer. Three, two. Okay. So you have to leave here the starting point. Uh, you can't, like, you have to do one thing, like, threshold should be the, if it is right, like, if the grade, if it is grade 0, like, limit threshold, 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 you have to return false, right? Like threshold. So if it is false, you have to threshold, and if it is 16, you have to do that much. So different. You can't go there. That much. It is okay. 0. Okay. 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 Just not to do here. You just to take 0. I think this must be pass the solution. Okay. So this one pass the solutions. Right. So it's like a binary search and the BFS algorithm. And let's see. I'm solved previously. What is the solution? Okay, so I solved using this, using that, I think using that much, I solved using the DSU, but today I solved today, it's like the, using the, using the binary search with the BFS. Okay, let's try to see how can we use the like, like, DSU. Okay, let's see. Mm, How can we store using the DSU? Water running gradually. So, like, we have to take, you have to take, right? Like, from 4, you have to take 5.6, 5.4. Maximum, minimum. So, let me, give me 2 minutes. I will back. Oh, sorry. So I solved this problem using the like binary search or the PFS. Let's try to see this question using the DSU. That means that disjoint set, right? So let's try to do like we have zero. How can we do like a disjoint set? Uh, Making the connection. Like if you want to use, if I want to use like a DSU here, so what we have to solution like what can I do here? Mm, the problem is like how to use. Okay, right? Mm, how to use like the problem is like how to use. We have how to use like mm, from here we can go here and here, and from each node we have to take a minimum, right? If you want to DSU, I solve this problem like PFS. If we want to using DSU, like we have to go here, here. Let's suppose here. So from the starting point to ending point, we have to find the from the starting point to ending point, we have to find the what 0, 1, 24, 2, 23. Okay. Now again 3, like from the each who is the parents of mine, who is the parents of mine, like I am connected to you. I am connected to you. I am connected to you. So give me the minimum. So it's one. Now let's go to here. Now go to here. Like I am connected. I am to you. I am to connected to you. But give me the minimum. So it's like mm, I am to connected to you. But we have to do like right. Mm, we have to do like like time and node, right? And taking the time and node, like, and going all direction, all its four direction, and try to taking the, okay. What I'm trying to do here, like, uh, we have, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can reach, make it connection. So let's try to do it with a DSU, right? Let's try to do this problem using the DSU, like, okay, let's try to do this question using DSU, like, we can take like, just like a style Kruskal algorithm, right? We can take, like, how can we take, like, we can take like a, like to take, like, just like the Kruskal algorithm, we can take it out, like, just do one thing, like take a map, take a map in, take a map and in, like just take a map and pairwise in time node. Okay, it's time, name it time node, right? Now we have what we have to do, like, what we have to do, like, here, time node. So what we have to do, just travel, just take and, so we have like, just just do one thing, right? Just take a grid dot size, okay, and the grid and m should be grid m dot size, right? Just what can you do now? Just travel all the way. Mhm. Just travel. Now what you have to do? Just you have to do like a time node, like time node. What time node? like a grid I comma j dot push push dot push, not a push, but you have to do like that. Just you have to like what we have to do like if we're traveling all the way, we have to do what we have to do like just like map grind dot push back, right? Push back, push back. What we have to do like what like grade I j and I and j, right? So now the question arises like how just sort it map, just sort the map because the map sort it with the time respective, right? It sort all the eh, with map values with the time respective. So just sort it like m dot time dot node begin, okay, and time node dot end. Now just what you have to do like just you have to do travel. So we have like this much is good, right? This much is all good. Now we have to travel all the way, and let's suppose we have to take a visited array vector vector sorry vector bull visited, right? And a vector just tell just do and zero, right? What we have to do like just mark it down all false. Now just like a crucial algorithm said, like for you have to travel map like a time node, and you have to take like a time or the like you have to take like a time should be the x dot first, okay, and the row should be the x dot second dot first, right? And the column should be x dot second, right? Now what you have to do just mark at R and C is visited, right? That means true. Now what we have to do? Just you have to do what? I think we have to do like taking the mark. We have to take a taking a mark and like a minimum. If it is unvisited, if it is visited, sorry, if it is unvisited, like if it is visited like R and C, you have to do nothing. Continue. Else, if it is unvisited, so you have to take like a you have to not this much, not do that like you have to take like travel all the four direction, right? All the four direction. You have to travel all the four direction, right? Four direction I plus plus, and this should be the new R should be R plus dx I, and the nc is equal to R plus sorry C plus dy should be I, right? This should be the new position. Now this should be the in of boundary, right? INC is equal to greater than n. If it is outside the boundary, right? This is checking condition, right? This should be the inside the boundary, right? Else, if it is visited, NR and NC is visited, you have to just do nothing, just you have to continue, right? Continue, do nothing. Else, what you have to do? You have to find like a previous in the previous node, like a previous node is equal to R plus M. sorry, R into M plus C, and the new node should be should be new node should be new node new node is equal to NC plus NC into I plus NC, right? Now we have to what you have to do, like you have to just unite them all. You have to just unite them all. Right, unite previous node and the next node and the new node, right? Previous node and new node, and mark them visited, all the good. This is good. Mhm. Okay. So what you have to do now, like you have to take the minimum one, right? You have to take the minimum one, like we unite them, and we have to take the time which is the minimum, right? Like, so what can I do here? Like we have to take the time which is minimum. So we are making connection like a 0 to 1. So it's a 1. So you have to take like a, okay, you have to take. So what we have to do? Like like first one do one thing, right? If the find parent, if the parent of previous node is not equal to the find parent of the current new node, then you have to do the unite, right? Then you have to do unite. Okay, unite, and time you are taking, and the uniting, then you are doing all that. Now let's suppose like traveling all the way. If we are marking all the way. Now let's suppose in the outing from that solution, outing from that one, this and this one good, this one is good. Now let's suppose if the find find parent of 0 equal to find parent of what, find parent of n into m minus 1, then you have to just return the t now. That means you can restore the t, else we can't reach t. So you have to do like a what, n into m minus 1. This is good. Now let's write let's write the template code for the parent and the rank. Okay, like a bull, sorry, bull, not a bull, but the int find parent. What should be int x, int x, int x. Now we have to do like if the parent x is equal to x, you have to just return the x. Else you have to do like a path comparison, right? Path comparison, like x is equal to find parent, and parent should be x. Now what we have to do? Sorry for that. Sorry. Just do unite, right? Unite them, like u v ultimate parents of u find parent of u and ultimate parents of v find parent of v, right? And if the ultimate parents of u equal to ultimate parents of v, you have to return. Else what you have to do, check the rank, right? Check the rank ultimate parents of u and rank and u ultimate parents of v. Then you have to just swap it. You can like u and ultimate parents of v. Now now you have to do like the parent of ultimate parents of v should be the ultimate parents of u, and the if the rank is equal, like ul u equal to rank of ultimate ultimate parents of v, you have to just do rank rank ultimate parents of u plus, right? You have to do just like that thing, and you have to take a like we can do like a like parent, like parent dot resize. What should be the resize? Resize should be the sorry resize sorry resize should be the what? Resize should be the n, like resize should be the n into m plus 1, and the 0, not a 0, but the rank should be the resize n into m plus 1. For the safety measures we are taking plus 1, right? And just travel all the way n into m, plus 1 plus plus plus, and the parent mark mark I should be I. Let's try to do. Let's see. Like what time node push back pairwise. Okay, in dot make pair. Hmm, I think this one is good. Why should okay, sorry. You are doing like great, but you are making a mistake. Like the grade I and j is equal to make 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 pair I comma j. This time, can I take it that like so you have to take like sorting order. You have to take like a sorting order, right? I just okay, so we have to take like a map in order, right? We have to take like a pay, not map. We have to take like a other. So you have to take like a vector pair int pair int int and int. Take like a time node, right? Just just do just do something like time time node dot push back 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 grid. Just do grid I and j and the I and j. Okay, just try to do you mean push back? Yes, push back. Why did you call the pushback? Yes, pushback. Am I making mistake, right? Here wise. Okay. You have to do it just like that. Okay. I am not taking a four directional. You have to make a four directional, right? Int dx 4 1 minus 1 0 0 and 0, right? And int dy should be 4 and 0 0 minus 1 and 1. Okay, we are taking the x, we are mark it visited. If it is visited, continuing previous NCR y NCR negative MC NC NCR determine. So the here should be the time and what's it? Huh? All giving the wrong answer. Why? Just why giving the all wrong answer? Like we have x dot first to second market visited, we market visited and traveling notes. So if it is out of bound, you have to continue. If it is visited, if it is visited, if it is visited, you have to continue. Yes. For the non-visited, you can't visit it, right? Yes, this much good. So it's like this is like using the disjoint set and which I solved it previously like this. This is using the binary search with the BFS, right? And the time complexity for this is like you can see like it's take like 4 alpha, right? This is the disjoint set like 4 alpha, and we are traveling from here. We're traveling n square. So n square, I think, and traveling on the map. So and traveling map not a size. So this would be, I think, n square log n. Okay. So this much. Now let's see the today's POTT problem. I solved this all the problem, right? I solved all the problem this. Now from yesterday, tomorrow I am going to all three problems. These all three are best problems, right? And many of the OA these problems asked, right? In the like if you are giving the assessment, online assessment, you can get this problem. Okay. Okay. So this is the uh, hard problem. What is the time constraint? Okay. What is question say? Your director, are director cyclic graph and not 0 to n. Okay, represented to be not array of length where you be post indicate one way communication of you to and with a recovery of post itna. Some node may be offline. Okay, you are given the boolean value online. True means I is online. Node 0 and ni is on always online. Okay, so a path from 0 to n is valid if the all the immediate path is online and total recovery cost of all the edges of the path does not exceed the key. The recovery cost does not exceed. For each valid path, define its a score as minimum edge cost along the path, minimum edge cost along the path, return the maximum path cost among all the. Okay, so it's like the binary search problem, right? Because the maximum minimum, right? So you this is given that the binary search problem, right? What this question said, like from 0 to n, you have to valid path if all the intermediate nodes of the path are online, all should be online, right? And the total recovery cost of the all the edges should not exceed the k. So and they define the score as the minimum size. Okay. So how can we do like from 0 we can do like 2 and 3. So it's like 0, 1 and 3. So 0, 1, 3 should be 10. Exceed. So path is invalid. 0, 7. So it's 7. So what is the solution of the 3? Oh, why is 3 given? Is equal to 3. So path should be okay. Path should be valid. Path should be valid and the edge should be no. So like we have to take a if we try to apply the binary search on number answer like answer binary search with on like can I apply like a 10? Can I reach to 10? So it's maximum like 3. So we can reach 3 because of the y3 the case will be 10. So it's 7. So we can reach the 7 and the minimum age among that all this is 7. Okay, age should be there. Okay. You have to maximize, right? You have to maximize within the all. So like a maximize the path score among all the values. If no value, so you have to return. So like from 0, you can go like a 0 1 and from here to here you can go here. So it's taking a time. So let's I think तो भैया ICPC बिजनेस क्या होता है? Oh, it's a competitive programming contest, right? Competitive programming contest where you can represent yourself. Thank you. That's it for the today. Thank you.